Yeah, so the image is formed at infinity when an object is placed at f of a convex lens. The location of the image formed is at infinity. A lens that is thinner at the middle and thicker at the edges is known as dash. Question number 3. What is the answer?
Is converging lens.
Is what?
Divergence, sorry.
Diverging lens. The image formed by a diverging lens is always dash.
It's always real, erect. No, sorry, virtual, erect, and diminished.
Virtual, erect, and diminished. Question number 5. An object is placed 20 cm in front of a converging lens of focal length 15 cm. Calculate its distance. Sylvester, take over.
Hmm?
Over to you. Solve that problem. Question number 5.
Like 20 centimeters equals to U, then F equals to 15.
Hold on.
Is that
You said 20 centimeter is equal to what?
equals to U? Is it correct?
Sylvester, you are the one taking the lead.
And 15
Oh,
is F.
F is 15.
Well, F will be positive since it's a converging lens. F will be positive. And the 1 over F equals 1 over U plus 1 over V. That's 1 over 15 equals 1 over 20 minus 1 over U. Then
Calm down, boy. Can't you see I'm writing it and you're rushing me? Which formula are we using?
I say 1 over F equals 1 over U plus 1 over V.
Why do you know it's plus? How do you know it's
Because
plus?
it's a converging lens.
The plus in here, not the plus for the F.
A plus for V because the image is real. You said, I'm not sure why it's plus. You
Because
not
I
really give
once
us a
told you,
reason why it's
I always
plus.
tell you how you will know. I always tell you how you will know. Hmm?
Yeah.
So how do we know?
If the image is real, that means V is plus.
So how do you know the image is real from this
Because it
question?
formed on the lens.
Sylvester, I'll knock your head though. How would you know the image is real from the question?
No, converging lens.
Is it all the convert? Is it in the
So I don't know.
in all cases that we have real image? I
Is it because
already
the
told
focal
you.
length is less than 20? I'm not sure.
And you will say the
It's
object,
less than 8.
the object is placed in a position that is greater than the focal length. That's why the image is real. If the object's position now, as this is 15, if the object's position is 10, this would have been a virtual image and this would be minus. Do you understand?
Yes.
So it shows that the object is placed behind the focal point. So that's why the image is real. So in that case, we're using 1 over f equal to 1 over u plus 1 over v. So once it is a converging lens, you already know that 1 over f, there will be no negative here. Then what will determine whether here will be positive or negative is if you interpret the question right. If it's negative, if it is virtual image, then here will be negative. If it is real, here will be positive. Then we have the 1 over f, which is 1 over 15, equal to 1 over 20 plus 1 over v. So we make 1 over v subject of the formula. We have 1 over 15 minus 1 over 20. So the LCM is 60. Here you will have 4, and here you will have 3. So this will give you 1 over 60. So that means V is equal to 60 cm. Do you see?
No.
Please take note of that. Are we together?
Yes. 60.0 centimeters. That's the answer.
Yes. Question number 6. Which of the following characteristics of light determines its color? Which of the following characteristics of light determines its color? Sylvester, answer.
The wavelength.
Equivalent. Question number 7. A converging lens of focal length 10 cm forms an erect image 3 times the size of a real object. Calculate the distance between the object and the image. Sylvester, over to you.
That means V is negative
Mm.
and F is positive. 1/10 equals to 1 over U minus 1. So this one, I don't get this one.
But we solved this. Me and you, we solved this.
When?
That's the question you keep asking me. When we are doing revision, I solved this problem with you. If not on the day we're doing revision, on one of our classes, I've solved this problem for you. You're asking me when. When I was showing you that if you have this, that if the object is formed, if the object is here, and the image is formed behind it, the distance between, because they are found on the same side of the object, because the image is found on the same side, if this is the image distance and this is the object distance, the distance between the object and the image will be V minus U. You won't don't you remember when we did this? Sylvester.
Yes, I do.
So don't tell me we didn't do it. We solved this particular problem together. We have 1 over u minus 1 over v. So we have 1 over f. F is 10 equal to 1 over u minus 1 over v. The question says that the all image formed is 3 times the size of the object. That means magnification is 3. So v over u is equal to 3. So this is the magnification. So v is equal to 3u. So we'll come back here and then put back our u, our v as 3u minus 1 over 3u. So the LCM is 3u. So we'll have 3 minus 1. So this will be 2.
Please give me a minute. My mom is calling me. You can.
So we cross multiply. We have 3u equal to 20. So the distance between the two, between the image and the object, the distance between the object and the image will be 20 minus 20 over 3.
No, sir, I'm back.
Sylvester, open your camera.
So I'm eating.
Open your camera.
I'm eating. No, continue. When I'm done, I'll open it.
Sylvester, you are eating in the class.
Just now, my mom came back with the food.
Now you see, um, our we find you from here. You understand what I did from here, right?
Yes.
So we cross multiplied. We have 3u equal to 20. So u is equal to 20 divided by 3, and then we have that we have u equal to 20 divided by 3 cm. And then that means that v is 3u and 3u is 20 cm. So then we subtract this 20 minus 20 over 3. We have 40 over 3, and that will give you 13.3. The rest, are we good to go?
Yeah.
Now the next question is for diverging length. So you see, without being told, you are using minus 1 over f. Because it's diverging length, you use minus 1 over f. Because the diverging length has a false focus. The focal length or the focus of the diverging length is not a true one. So that's why we use negative. And then it always forms a virtual image. So we also use negative here. So we're going to have minus 1 over f. And our f is 30. And then u is what we are looking for, minus 1 over 20. So we take this over to the other side, becomes 1 over 20 minus 1 over 30. Sylvester, are you following?
Yeah.
Equal to 1 over u. So now the LCM of this is 60. So have 60 is divided to have 3 minus 2. So this is 1 over u equal to 1 over 60. So then, therefore, u is equal to 60. So, put together.
Yes. Um, are you here?
Sylvester,
Yes.
are we together?
Yes.
So now, question number 9. Can you see my screen? Can you see question number
Yes.
9? Now, it says, at what position will an object be placed in front of a convex lens in order to obtain an image at infinity? This is like,
I think it's D.
not you think it's the, you have to pick the right answer. This question is like the other
It's
one we saw,
between F and C.
Sylvester. This question is like asking this. This question
I
now, you see
know
now.
that the
Uh-huh.
answer is B. Abi,
Sylvester, look at this question. Look at this question number 2. What was your answer? When an object is placed at F,
C. I
you
know
said
now.
the
That's why I
answer
say
is,
F and C. F and the mirror.
what are you saying? F and the mirror. Is there any F and the mirror here?
F and C. I don't know how they say it there, sure.
Look at the options now. Or now I say F and C. Do we have any F and C?
I said D. Maybe it's
D,
D, sure. I'm not sure.
not maybe it's D. Don't you know where center of curvature is again?
No.
That one C is not optical center is C, not center of curvature. Do you understand what I mean? This
Mm.
this if you have the lens like this, here, if this is center, this C is not the center of curvature. This is F, and here is 2F. It is the 2F that is the center of curvature, not this. This one is the optical center. If the question, if this, even if this is the optical center, it's still not D, because if the object is placed between the center, the optical center, and F, it will be here. Means that the image that will be formed will be an erect and upright
I know.
image. Uh-huh. So it can be D. The answer is the
How
object
will it
is
be
placed.
erect? Is formed is at yeah. It's placed at F.
For you. Dispersion of white light is the ability of white light to do what? What's the answer?
You break down into its component colors.
The instrument used to view stars is the dash.
Telescope.
The following devices use lenses in their operations except
A periscope.
presbyopia is defect of the eye resulting from
A.
hmm?
A. We call the ciliary muscle.
Question number 14. The focal length of eyepiece of an astronomical telescope is f1,
I
while the
know
focal
this
length
one.
hmm?
I'm just going mom. Let me wash my hand.
Okay, I see.
Listen, back.
Are we together? Sylvester, are we together?
Yes.
So now the focal length of the eyepiece of an astronomical telescope is f1, while the focal length of the objective is f2. For normal adjustment, the angular magnification is what? What's the answer?
For this question, I failed it.
But do you know these questions, some of these questions, most of these questions, you are not supposed to fail them because me and you, we did it together. Even solve the problem with this formula. F2 over F1, normal adjustment. I took my time to draw the two cases for you, prove the formulas for you. You enter exam hall only for you to pick the right option, the formula. You say you failed it. Somebody from outside now will look at it and say it's the fault of the teacher. I cannot, after teaching you, I'll still come and be the one to help you to revise what I taught you. Hmm. The use of lenses is not applicable in the dash. What's the answer?
Periscope.
Good. Number 16. The lack of accommodation, which is due to the hardening of the eye lens and is usually with the onset
Presbyopia.
presbyopia. The property of an eye of the eye, known as its power of accommodation, is
I don't know this one.
controlled by the ciliary muscle. The power of the eye, known as its power of accommodation, is controlled by the ciliary muscle. If the ciliary muscle refuses to adjust, the the um, the lens of the eye will not focus its image on the retina. So it is the contraction and the expansion of the lens, which is led by the ciliary muscle, that causes this, brings about accommodation. So the power of accommodation, which is the power of accommodation of the eye lens, is because the ciliary muscle can adjust the focal length of the eye so that image can be focused on the retina for clear vision. Question number 18. Sylvester, are we together?
Yes.
We have less than 1 minute. You have to log back in and then we'll continue from there.
So are we going to finish everything today?
No. When we come back, we spend 15 minutes and then Chizu will come in. Is that okay?
Okay.
All right. So in the next 15 minutes, in the next 10 minutes, you log back in. Okay?
Okay.
All right.